Okay, let's take a look at tutorial 6, question 1. Let's highlight some of the important information. Suppose that the prices of European call and put options on a stock that expires in 12 months are, okay, and a strike price 120 are 20 and 5. So the 12 months means that T is equal to 1 year. The strike is 120, that's K. Call and put at time 0 are 20 and 5. Oh, and we've got the stock price today, 130. Okay, so part A, what opportunities are there for arbiters? We don't have R. So R is unknown. So we need to look at all the different cases and see what opportunities are available. Okay, so standard approach using the put call parity. Okay, we have some information at time 0. We know what this should be, what this should be equal to. So we're going to check. We got the portfolio using the put, the call, and the stock. We know if we buy a put, buy a stock, and short a call, the value of the portfolio is 5 plus 130, take away 20, which is 115. And this should be equal to, well, we take the strike price and we discount to today's money. If we do that, we get 130 e to the minus r, and that should be 115. They should be equal. Okay, so let's look at the cases. Case 1. Let's suppose that they're not equal, and the right hand side, the ke to the minus rt is bigger. Okay, so some simple rearranging. We got the portfolio is 115. It's dominated by 130 e to the minus r. Some rearranging. This gives R is less than around 4.25596%. We can write as decimal. So this tells us that the portfolio is cheap. Okay, it's cheaper than the strike price discounted to today's money to compare them like for like. So we want to buy the portfolio. Okay, it's cheap, so we want to buy it. Okay, in part B, we're going to try some numbers and see how much profit's involved. For now, we're just going to calculate the rates and decide on some strategies. Case 2, let's look at the opposite case. Let's suppose the portfolio at time 0 is greater than ke to the minus rt. So the portfolio is bigger than the strike price discounted to today's money. This means that the rate must be bigger than 4.25596%. And in this case, the portfolio is expensive. So we want to sell it. Okay, we want to go short on that portfolio. So we want to do the opposite. Okay, so the third case, the most simple case, this is the case when quality holds. So the portfolio at time 0 is ke to the minus RT. Okay, so we can see that R is 4.25596%, just from earlier. In this case, there are no arbitrage opportunities. Okay, and that argues all the different cases. Right, so that is part A. Part B, calculate the profits of arbitrage portfolios if the interest is 3% and 8%. Okay, so let's take a look at the first one. Suppose the interest rate is 3%. I've done everything as decimals, I'll keep it as decimals. So in this case, this fits into the first picture, case 1. So in case 1, we said, let's take a look, if this is true, which it is, portfolio is cheap, and so we want to buy it. Okay, so we want to buy the portfolio. So we borrow some money, 115. That's the cost of the portfolio. And we purchase it. Okay, so what happens in the future? Let's calculate the future values, FVs. See what the profit would be. Okay, so at time t in 1 year, we have the value of the portfolio. There's lots of hedging involved. This is going to be fixed. Take away what we paid for it. So we borrowed 115. We need to compound to future value. So we're going to divide out the discounting factor. This will give us the future value. And let me just say how I did that. So maybe it's not so obvious. So this discount rate from 0 to t, it takes some future value and brings it back to the present value. And so just dividing out by the discount rate, we get the future value. Okay, something quite small there. Dividing by the present value by d gives the future value. Okay, so the future value of the portfolio, because we've hedged, is k, and the price that we paid for it, well, continuous compounding. So we're using e to the rt. Drop all those numbers in. The strike is 120. If we compound at 3%, the amount that we borrowed, 115e to the 3%, which gives us a positive number, which means a profit of £1.497729. Okay, so this is the profit that we would achieve if interest rates, the risk-free interest rate was 3%. Okay, how about the other case? So we've done 3%. How about 8%? Let's take a look at 8%. So case 2, if the rate is bigger than about 4.3%, yes, ours is 8, then we want to sell it. Okay, so we want to set up a situation where we're selling the portfolio. So we're going to use case 2. We short sell the portfolio. Okay, if you go short on the portfolio, you're going to receive some money, and we're going to invest this income from the short. So let's calculate the profit. So in the future, the portfolio is going to be worth pi t. We don't actually own this, we need to pay for it. So it's a negative pi t. This is a cost that we need to pay. And with the money that we received from the short, we're investing at 8%. So we want the future value. So we divide out by the discount rate, similar to the previous case with 3%. Let's calculate these numbers. So we need to pay minus k to cover the short. We receive some income. Let's put all these numbers in. So we get minus 120 plus the investment income, which by my calculation is £4.578013. And there you go, that completes question 1 on tutorial 6.